Good morning, my dear children. I am going to continue this chapter, classification of elements and periodicity in properties. In this chapter, I have already discussed about various topics. Now I am going to continue my next topic. That one is periodic properties. What is periodic properties? Those properties of elements which get repeated within a period and within a group. Means those properties which varies within a period from left to right and within a group from top to bottom. These properties vary regularly, means either decrease or increase within a period, and in the same way this property gets repeated in another period or another group. Here some properties which are in our course are atomic radius, second one is ionic radius, third one is ionization potential, fourth one is electron gain enthalpy, fifth one is electronegativity, sixth one is metallic and non-metallic character, and seventh one is nature of oxides. These are the various periodic properties which are in our course to study. Now I am going to discuss about atomic radius. First periodic property is atomic radius. What is atomic radius? Atomic radius is also known as atomic size. Atomic radius, or you can say atomic size. What is atomic radius or what is atomic size? You know that all atoms are spherical in shape. They have a nucleus surrounded by various shells. These shells contain electrons. What is the definition of atomic radius? The distance between center of nucleus to the valence electron, means the distance between center of nucleus to the outermost electron. This distance is called atomic radius. Atomic radius is measured in angstrom or nanometer. Both of the units are used to express atomic radius. Atomic radius is of three types. Atomic radius is of three types. First one is covalent radius. Second one is Wondrous radius. And third one is metallic radius. Means atomic radius is of three types: covalent, Wondrous and metallic radius. What is covalent radius? When two atoms combine together by forming covalent bond like Cl2. In Cl2, two chlorine atoms are bonded together by covalent bond, and the half of the distance between two nuclei bonded by covalent bond, this half part is known as covalent radius. Means in homonuclear diatomic molecules like H2, Cl2, O2, N2, etc. These are the homonuclear diatomic molecules. Means both of the nuclei are of same types. H2, Cl2, O2, N2, etc. In homonuclear diatomic molecules, the half of the distance between two nuclei, this half part is called covalent radius. For example, the distance between two Cl nuclei is 1.98 angstrom, hence the atomic, or you can say covalent radius of Cl equals 1.98 by 2, 0.99 angstrom. This is the covalent radius of chlorine. What is van der Waals radius? Van der Waals radius is, in solid state, you know that various atoms are arranged in this way. In van der Waals radius, the half of the nuclei between two atoms, corresponding atoms, or you can say adjacent atoms, this half part is called van der Waals radius. Here no covalent bond is present between these atoms. Only they are glued together. They are nearer to one another. No any bond is formed here. Here from this nucleus and this nucleus, the half of the distance between two nuclei, this is called van der Waals nucleus. Metallic radius. In metals, you know that various atoms are arranged in this way. This is only for metals. This one is for non-metals or metals both, in which atoms are combined together to form a solid state. In metallic radius, the metal atoms are present like this. The half of the distance between two nuclei of metal atoms. These are the atoms of metals. The half of the distance between nuclei of two atoms, this half is called metallic radius. All of them are nearly same, but here some of the difference is present. These are about the atomic radius and various types of radii. Here one important question: which of the radius is greater and which of the radius is smaller? In comparison, this van der Waals radius is larger than metallic radius, and this one is larger than covalent radius. Means you can say van der Waals radius is largest and covalent radius is smallest. Okay. Now I am going to continue. How does atomic size or atomic radius vary within a period and within a group? In any period, on moving from left to right, in any period, either second period or third period or any one, in any period, as we move from left to right, the atomic size decreases. Why this so? As we move from left to right, the number of valence electrons increases. Means number of outermost electrons increases, which causes increase in effective nuclear charge. Effective nuclear charge. As we move from left to right, the number of valence electrons increases. Here the first one is alkali metal like lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. Here the configuration is 2-1, here 2-2, 2-3, 2-4, 2, 5 and so on. Here 2, 7 and this one is 2, 8. On going from left to right, the atomic size decreases as follows. But here in noble gas, the atomic size is slightly larger than halogen. Means you can say the alkali metal has largest atomic size and halogen atom has smallest atomic size. In any period, alkali metal has largest size and halogen has smallest size. And opposite to this, within any group, on moving from top to bottom, atomic radius increases. On moving from top to bottom, atomic radius increases. This is due to increase in number of shells. On going from top to bottom, the number of shells increases. Here 11Na, 281, 19K, 2881. On going from top to bottom, number of valence electrons increases, which causes increase in atomic radius. In this way, within any period, on going from left to right, atomic size decreases, and within any group, on going from top to bottom, atomic size increases. This is about the atomic size. This is the first property of this period table. Okay. Now, in my next lecture, I will discuss about next all other topics. Okay. Thank you.